Awesome. So my name's Hashan Mendis. I'm actually from Leap Australia, so we'll talk a little bit about what we do in a bit. I wanted to talk today about simulation and Industry 4.0 technologies and about how companies are really using it in the current field. Right. So a little bit about Leap Australia. So we're a trusted engineering solutions provider. We've started around 1996 and we've got around 50 people around Australia and New Zealand. We are technically focused, so we're not just about sales, we're also about training and support as well as things like consultancy. So we really help out our customers however we can. We're the distributors for some different software platforms. So we've partnered with Ansys, who's the largest simulation platform, and we'll be talking a little bit more about that in the presentation, as well as PTC as well. So they've got technologies when it comes to dealing with things like CAD, product lifecycle management, things like the Internet of Things, and also augmented reality. On top of that, we've also got a range of complementary products that cover things like discrete element modeling, fatigue, 1D flow networks, rendering, and a lot more as well. So if it is something that you're interested in, or if there's something here that we're not going to be talking about, feel free to have a chat with us at the actual booth. So what I wanted to talk about is what is really driving this digital transformation, and why are companies looking at things like simulation and industrial 4.0. So, I mean, the market at the moment is pretty competitive, and what's happening is that we've got products that are actually being put out there that are a lot more complex from the past. Products also need to be delivered to the market a lot faster as well. And the quality of the products either needs to stay the same, but in reality, they really need to be increasing as well. So that's why companies use simulation and industrial 4.0. So how we kind of sit into this. So we work with Ansys, who's a market leader when it comes to a true simulation platform. We've got a wide range of physics that we can really talk to and address. Across them all, we've got plenty of softwares out there. So if it is something that you guys are interested in, let us know and we can have a chat about that afterwards. Right. So this is the reason across all of these different industries, all these companies rely on the actual Ansys platform. That's one of the reasons it's great to actually learn it as well, because there's so many companies out there looking for engineers with these types of skills. On top of the simulation side of things, another advancement that's really come about over the last couple of years is about really augmented reality and the Internet of Things. Now, augmented reality, there are a couple of things that we can do there, right? So we can use this as a tool to actually market your product, show off what you've got, things like your digital prototype. It can be used also as a training tool, so we can overlay information on there. So it's all about how can we teach these people a lot quicker. We can also start to augment, simulation information and sensor information in the actual field as well. So overlaying data for things like, for people out there. And even when it comes to things like R&D, so when it comes to communicating high-level ideas to maybe other professionals, this is something that everyone can be doing. So when it comes to the educational journey, right? So I'm just going to take simulation as an example. I mean, the idea is that at university, you're really starting your journey off in the classroom and you're laying down that foundation work. So if we're thinking about simulation, you guys are probably learning a lot about things like FEA and CFD. So this is really the groundwork. What we're doing is we're progressing as an engineer, maybe through higher degrees, maybe you've got some electives or in an industry experience. We're building more complex simulations. So we're doing multi-physics simulations. We're really replicating the real world. When we've got products in mind, so through the whole CAD stage, through the the hand calcs, as well as these simulations, we're creating what's called this digital prototype. And this digital prototype, building all these systems into it, we're able to build, kind of optimize, validate, and even verify complex systems. And once the product is actually out there on the field, this digital prototype is still being used. It's acting with what's called a digital twin. So the digital twin is using information that's out there in the field, and it can give you some sort of insight into the actual product, the current performance, things like maintenance, troubleshooting issues. It allows you to also anticipate unforeseen circumstances and inform the next generation. So this is some of the things that I wanted to talk about in this specific presentation. So I want to share with you some of the actual projects we've helped out with in the actual industry, as well as through RMIT and what's been happening out there in the world. All right, so I'll just take 1 second. I'll just check if there's any chats. Cool. Awesome. So I wanted to talk, we'll start off with the digital twin concept of it, right? So like we were talking about before, so through the actual design process, we create what's called, this digital prototype. So this consists of things like your CAD data, your hand calculations, your simulation actual results. When the product's actually manufactured, we've got a physical product in the actual real world, right? Sensors are becoming smaller and cheaper, and connectivity is becoming easier as well. So companies are actually building them into their actual product. Now, these sensors can be feeding back information back to the actual manufacturer. Using things like an IoT platform, for instance, ThingWorx, we can link that real world data back to our actual our digital prototype, creating what's called this digital twin. So this digital twin, like we were talking about, gives us better insight into the actual product state, performance, and the behavior as well. So let's look into that in a little bit more detail. So normally in the actual design process, we've got some sort of assumptions about things like the loading conditions, what's happening out there, right? When we've got the product out there, we can actually look at what's happening, in reality. How are our customers actually using it? How often do we get these types of use cases, right? How often is this guy making this jump? Is my product going to be okay, right? Using things like the IoT platform, again, we were saying we can bring that information back. What we can start to do is start to process it, validate our initial assumptions, and allows us better insight into the actual product, right? How are our customers using it? Can we identify use cases that we initially didn't anticipate? Where can we actually reduce things like costs? And have we potentially discovered new segments because of how our customers are actually using our products? So again, this data, though, doesn't necessarily just have to stay there, right? We can bring that data back into our actual simulation platform, right? And we can use it. So we can build things like virtual sensors. We can then start to replicate reality, right? This really allows us to, again, understand what's happening at the moment with our product, but also, how does this kind of optimize the next generation? What can we really learn about the next generation of our products? So we can use this kind of the concept of the sensors out there in the real world, bringing back information, and we can connect up other things as well. So in this particular example, we've got building equipment, so we can use the Internet of Things, but it can also apply to things like CNC machines or even fridges and appliances, right? A lot of these new machines are actually coming with these connected devices, so it's a matter of connecting it and extracting the relevant information. But you can also use for old machines that aren't connected, sorry, you can also use things like Raspberry Pis with like a Wi-Fi module. So that way you can send back specific information. So we can create a dashboard like this. So it gives us, a bunch of information about all our IoT assets that might be out there in the field. It's streaming back some information and we've got something about it, right? We know something about the actual product. What it allows us to do, so we can go into these specific components, we can investigate it in a lot more detail and understand what the current and the historical conditions of the actual equipment are. We can also start to take in things like external data sources from the actual asset and start to understand really how could we be using this product. With this actual data, right, we can use it to make some sort of predictions, right? Things like the operating cost, how often is it being used? When will this thing actually need maintenance as well, right? So, that was an example, maybe a little bit closer to home. But if you're in the wind turbine turbine business, we've actually got a turbine that's offshore. Maintenance can be quite costly. In this particular case, we've actually got many different rotors as well, many different motors, sorry. So what we're able to do again is using the IoT information that's out there, connecting it with things like simulation, is really understand exactly when do we need to maintain each of these motors. With some clever algorithms as well, we can also actually determine what the remaining life of that specific motor is. So here's another example of AR being used as a teaching tool. So this is actually BAE Systems. In this particular example, they've actually created this experience using the Microsoft HoloLens. So that HoloLens is actually, augmenting it into the workspace. So by creating these kind of step-by-step instructions, we're able to really teach someone how you can assemble this together, put it together as well, and you really don't have to be juggling around with things like physical manuals. So it makes the teaching process a lot easier, as well as the actual assembly process as well. So this is an example we've also been helping create with a company called Tech Equipment. So these guys do equipment for universities when it comes to teaching. So in this particular case, you can actually see though, when the actual weight changes location, you can see the stress and strain data gets updated live. So we're using AR to actually show people what the stress and strain is. That's not normally there. And we're also overlaying simulation results, and those simulation results are actually getting updated when that weight gets changed. That's great. So it gives us a lot of insight into the actual current design, right? But what we can also do is look at things like alternate design. So on the bottom right, we've actually got an I-beam situation, right? So you can actually say, if this was this particular case, this is how we might actually see it. So you can see how we can use augmented reality to really add information to what may not be there at the moment when it comes to things like adding simulation results or pictures, videos, or just raw information, things about what the stress and strain are doing. Here's another example of a consumer product. So this is Dyson. They've been using Ansys, and they needed it to actually optimize the bladeless fans that they've been creating. So the reason they chose Ansys is because they were able to simulate the flow patterns around the actual fan, and they were able to start to optimize that design as well. By utilizing simulation, they were really able to iterate through a lot more designs compared to just relying on things like physical prototyping. So this is how some of these companies, these consumer companies, are using it. This is something a little bit different. So this is the actual, this is a manufacturing example. So the goal of this simulation was to actually simulate the heat press process. So skis are a multi-layer composite bonded by an adhesive. So the adhesive curing depends on the actual heat and the pressure. So this production step gives the skis its actual shape, its stiffness, which determines the actual characteristics and the quality of the ski itself. So after some simulations were performed and validated, it gave insight into the problematic areas of the ski and the actual press bed. So the use of simulation in the ski manufacturing process, again, saves costs, requiring fewer physical prototypes and allowing engineers to explore, completely new and unconventional approaches to ski design. This is not obviously just for ski design. We've got plenty of other clients that use it for their individual manufacturing processes. Something a little bit closer to home. So this is the AMP building in Sydney. So in this particular example, so this is quite high up. We've got a plant room where we've got people inside there, or we can have people inside there, and we've got these cooling exhausts and intakes as well. So it was actually struggling with some poor recirculation conditions. And all this hot air was actually coming back into the actual plant room. So this is, again, one of our consulting jobs. So we were actually contracted to help out in this particular case, provide a little bit of insight into what the actual problem is, like why are we getting this, and some sort of solutions to improve it as well. So we used Ansys, our CFD platform, to actually change the louver configurations, and it showed that there was considerably less recirculation, leading the plant room conditions to be improved from the actual equipment. Here's another example about a court case. So unfortunately, in this particular case, there were some people that were killed. So in this particular accident, again, there were no living witnesses. and the actual recording equipment wasn't actually working. So Leap was actually asked to come in and help determine what the actual speed of the train was for it to derail like this. So this is an image just showing at the end, when we ran the simulation, we can compare it to real world, how accurately we can get our simulations to line up. So the engineers, can use this data in the future, again, to understand exactly what's happened and ensure, this doesn't happen again. So the other things I wanted to talk about is our partnership with RMIT as well. So we've been, working with RMIT for quite a while. We've got quite a bit of graduates from there as well, and we've been helping out with a lot of their projects regarding, the Ansys side of things, the PTC, as well. So this is another example again of, this is actually a student's project. So they were overlaying flow results as well as structural results on this PC9. So this is actually in the Avalon Air Show. So again, it's great to show off exactly what you've been doing to someone that may not be, necessarily an engineer, but they can understand visibly, all right, I get what this person is trying to show me. During the F1, we were partnered again with RMIT. To show off a little bit of the AR. So in some of these videos, right, we've got some of the use cases of AR for marketing, right? On the top left, if we don't have something, we can use an iPad, put a digital prototype down and then look at it in a lot more detail. We can start to overlay information, flow results as well. If we've got something there, we can augment it, right? What happens if you had a red Mustang instead? What would it actually look like? So we can take that physical, the physical model and overlay information on top of it. If you don't have anything, you can actually create one-to-one kind of scale experiences. So either using something like an iPad or a HoloLens, you can actually explore through it as if you've actually got a Mustang in front of you. Another thing that we've helped them out with is a hackathon. So we partner with them to create this IoT and augmented reality hackathon. So in this particular case, the companies actually posed real world industrial problems and the students created the solutions using IoT and AR within 2 days. So that was really great. On the bottom right as well, you can see we helped them out with the mini factory as well. So this is again a collaboration between the two of us. So in this particular case, they had this mini factory. It was a bit of an old machine, but we were able to hook into it and modernizing it using some Raspberry Pis, and then feed that information back. Right. So using that. That data, we can perform some sort of analytics onto it if we wanted to, or we can overlay information, right? If for customers that might be out there in the field. Some of the things that we do is that we support these types of events, but we also support the engineering teams as well. So two of our long-standing kind of sponsors is the RMIT Electric and the RMIT Combustion race team. So we've been sponsoring them with things like software training and technical support as well. I was actually from the RMIT team, so it's something really helpful. I'm really grateful for Leap for helping us out when we begin with and going through that process as well. The other thing is the Hive Team. So this is a rocket team at RMIT. So the goal of the actual competition is to launch a rocket off and it needs to get to a specific altitude. So these guys all go through the process of actually designing and going off to the actual competition. We also help with what's called the Boeing Go Fly competition. So this team's called Aero, and the idea of this competition is actually to create a personal flying device. So we help them out through some of the simulation process as well. So next I want to talk a little bit about getting involved. So hopefully you guys have seen, the transformations that industry and students are really going through. Part of it's due to the actual pandemic, but this was always happening. And hopefully you can see how, some of your actual projects, or somehow some of the industries you might be interested in going into, could be using some of this technology as well. So I wanted to say a couple of things though. If you are an entrepreneur, you've got a product in mind, you've got something like a startup, please do have a chat with us at the actual booth. We offer startup bundles for people starting off. And the idea is that it gives you the same tools as these industry leaders to really get you in the door and get you, churning through your designs to really perfect what you've got. If you're a current student, you can actually reach out to us on support, which we'll talk about a little bit later on. And you can actually, talk to if you've got a project, whether it's an FYP, a master's, or a PhD project, and you've got some sort of, some sort of like CAD, IoT, AR, or simulation work to it as well, you can actually reach out to us and we'll help you through that process. The other thing is that, if you're looking for a job, this is a great thing to actually add to your CV, because there are people, a lot of industry out there looking for these types of skills. It also just goes to show that you're a well-rounded engineer. And if you're in a job already and you reckon, some of these things that I've talked about, you guys might find really useful for your particular job, again, there's plenty of resources that we'll talk about. So, and feel free to actually reach out to us as well. So regarding technical support, so again, like I was saying before, we're not just a sales organization. We're about providing technical support as well. So, there's a support email address that you can see on the screen. We provide it not just to our customers, but also to the universities as well, and to the university students. So if you're running into some problems, or you're starting off and you want a little bit of help, you want to make sure maybe you're going down the right direction, definitely contact us on support. Tell us a little bit about what your actual problem is, maybe what your project, where you're at the moment, and your supervisor, and we'll definitely be able to try and help out. So if you're not unable to actually get to university and maybe use some of the computers out there, Ansys actually has a student download, so you can actually use it for your homework, for your projects, and for your competition as well. So there's a link out there. So if you Google Ansys student, you'll also be able to find it. So a lot of the software is out there. So if you need it, you can have a look at that. On top of that, PTC have a very similar approach as well. So if you're looking at things like Onshape or Creo, which are CAD tools, the Vuforia Studio, so a lot of the AR stuff that you've actually seen has been created off Vuforia Studio, and ThingWorks, again, IoT, the IoT tools. So if you guys are actually interested in some of that stuff, again, talk to your university, because RMIT does have access to a lot of this stuff. But you can also hop on the actual website. You can check some of this stuff out here, and you can really start to learn yourself. So then the other thing is YouTube. So we've got a YouTube channel that's got a lot of material on there. So we try to do a lot of work and get a lot of resources on there. Definitely have a check out of some of the actual playlists. So we've got playlists on things like, the simulations, working with some of the race teams, lectures, as well as demos as well, and then information as well. So things about what is augmented reality, what is things like Discovery Live. We also have a couple of blogs. So we've got a FEA blog where we try to write about things that our customers are actually asking about, right? So plenty of topics over there that you can have a look through. We do the exact same thing for CFD as well. So we've got plenty of blog posts about things like turbulence modeling, right? Understanding some of the different things that might be there. And also the product design as well. So we've got a product design blog that you can also have a look through and really just keep up to date with what's happening in the workforce. If you are, so Ansys has what's called this learning forum. So if you actually want to learn about simulation, maybe you haven't picked it up as an elective, or it might be coming up, you can hop on here as well. And we've got plenty of content. There's also a discussion forum as well. So if you're running into a problem, again, feel free to have a chat with us, but you can also check it out on this discussion forum. This is also great for, if you're out there in the industry and maybe you didn't do a lot of the fluid dynamics or FEA subjects, you can actually run through some of this stuff and it talks you through it as well. And again, feel free to have a chat with us about exactly that same stuff. Plenty of resources. So Ansys also has their own YouTube channel, so how-to video, technical tips. They've also got a blog as well as an Advantage magazine. So again, you can keep up to date with what the actual community, the simulation community, is doing, as well as how there are other companies out there that might be using it, and potentially how you could potentially use it as well. PTC have a very similar thing as well. So they've got a PTC network on top of all the software that they provide. They've got an actual like program kind of discussion. So you can hop onto there, and if you have any questions, you can ask. You can kind of peruse through it. Again, with PTC, you can have a chat with us as well. And on top of that, there's the learning resources at the LEAP Academic Portal. So this is something that we've created with Ansys training material. You can pop onto there and you can actually go through a lot of the training material, go through some of the past online trainings and lectures that we've done, and really understand it. What I wanted to kind of end off with is that fact that these trends are here to stay. So this is a quote from McKinsey. So these trends, there's always been a trend to be a little bit more distributed, mobile, and create an agile workforce, right? That's always been there. But due to this current pandemic, it's really been accelerated, and it will continue to do that into the future as well. So, a lot of the stuff you guys just saw, probably a lot of the things you're learning about as well, you guys will be using a lot of this stuff in the actual workforce as well. So it's really important you understand how you can use it. Now, please stay connected with Leap. So we're on all of our socials, so LinkedIn, Facebook, Twitter, Instagram, and YouTube. Feel free to have a chat with us at the actual booth as well, and you can hop onto our website if you want a little bit more information, you want a little bit of help with your project, or if you're a customer and you want to use some simulation as well, you can have a chat with us as well. Awesome. Thanks a lot for your time.